So good day, everyone. Good day, Sir Fernandez. We're tasked to report about distributed control systems or DCS. So these are requirement in a subject instrumentation and control. So the reporters are yours truly, Mary Grace Cueva. Next is Mr. Kenneth Argasaho. And last, Mr. Kyle Philip Nam. So to start, the instructor is Engineer Xavier Fernandez. So let's start with the overview in the DCS. So generally, the concept of automatic control includes accomplishing two major operations: the transmission of signals or the information flow back and forth, and the calculation of control actions or the decision making. So carrying out these operations in real plant requires a set of hardware and instrumentation that serve as the platform for this task. So DCS, or the Distributed Control System, is the most modern control platform. It stands as the infrastructure not only for all advanced control strategies, but also for the lowest control system. So DCS plays a vital role in manufacturing industries as they are used to control and manage the processes. The networking capabilities of DCS are useful in the process management, and the inputs or the resulted outputs can be analog signal or discrete signal. Distributed control systems, on the other hand, are used merely in the innovative emerging process industries as an extension of traditional controllers. The major concept of DCS application is derived from the idea of decentralizing the control unit and establishing a common network between the engineering stations. So before that, let's have the historical review of the automatic control system. So to follow in the historical review, we have three: the pneumatic implementation, second is the electron analog implementation, and the digital implementation. So let's have first the pneumatic implementation. So in the early implementation of automatic control system, information flow was accomplished by pneumatic transmission, and the computation was done by mechanical devices using bellows and spring or other devices. So the pneumatic controller has high margin for safety since they are explosion proof. So when we say pneumatic, it is a system that uses compressed air to do work, and they capture air, transport it around a circuit, and accomplish designated tasks with the generated energy. These are present in both manual and automated machine, and within the construction or in the mining industry, for example. So in short, pneumatic machines have the vast amount of applications. So there are two fundamental problems associated with the pneumatic implementation. First, in the transmission, the signals transmitted pneumatically are slow responding and susceptible to interference, so slow SIA. And calculation, the mechanical computation devices must be relatively simple and tend to wear out quickly. So let's have the electron analog implementation. So electrons are used as the medium of transmission in this type of implementation mode. So computation devices are still the same as before. Electrical signals to measure signals converter and vice versa are used to communicate between the mechanical devices and the electron flow. So same as pneumatic implementation, ang electron analog implementation have two problems man said siya. So in transmission, analog signals are susceptible to contamination from stray fields, and signal quality tends to degrade over a long transmission line. And in calculation, the type of computations possible with electronic analog is still limited. And lastly, we have digital implementation. So the transmission medium is still electron, but the signals are transmitted as binary numbers. Such digital signals are far less sensitive to noise. As we all know, noise is the disturbance in the control system. So the computational devices are still computers. Digital computers are more flexible because they are programmable, and they are more versatile because there is virtually no limitation for the complexity of the computation. So let's have the modes of computer control. So modes of computer control, we have two, the supervisory control and direct digital control. So supervisory control, it involves resetting the set point for a local controller according to some computer calculation. So, and the direct digital control, by contrast, it requires that all control actions be carried out by the digital computer. So both modes are in wide use in industrial applications, and they are incorporating modern control technologies. Measurement are transmitted to computer, and control signals are sent computer to control bulbs at a specific time interval known as a sampling time. So next is the figure of computer control modes. So here at the lower part, direct digital control mode, na siya vault setting from a computer. And in the upper, the supervisory control mode, na siya local PID controller, which padong siya signal from the computer. So mo na siya ang modes of computer control.
Computer control networks. So the computer control networks performs a wide variety of tasks. Data acquisition, serving of video display units in various laboratories and control rooms. Data logging from analytical laboratories, control of plant processes or pilot plant. The computer network can be as simple as an array of inexpensive PCs, or it could be a large commercial distribution control system. So we have the parts of computer control networks. So first is the small computer network. It is an inexpensive and straightforward way to deal with the systems is to configure a network of personal computers for data acquisition and control. Next is the programmable logic controller. It is exclusively specialized for non-continuous systems such as batch processes or that contains equipment or control elements that operate discontinuously. Commercial distributed control systems, or it is a DCS, is then a powerful tool for any large commercial plants. So we have the access a large amount of current information from the data highway from its commercial distribution control system. It sees the trends of past process conditions by calling archival data storage, alternate quickly among standard control strategies, and readjust controller parameters in software. So it has a site of full engineer that can use the flexibility of the framework to implement his latest controller design ideas on the host computer or on the main control computer. It is readily installed on a new line, measurements together with local computers for data acquisition, and then use the new data immediately for controlling all loops of the process. So we have the figure for the functional levels of typical DCS. So the figure shown that the lowest level in level 1 It is the plant floor where the process equipment controls, devices, sensors, and intelligent instrumentation are located. At the direct control level, microprocessor controllers, executive loop control, perform logic functions, and analyze process data, then transmits control signals to the field devices on control system. So the process data collected at level 2 is transferred to level 3. At this level, process operations and engineers use operator consoles that have video displays to monitor and adjust the various processes being controlled by the system. Also at level 3, process and control engineers implement advanced control functions and strategies. And members of the operations management team perform advanced data collection and analysis on process information. The various plant management system, such as inventory management and control, billing day, invoicing, and statistical quality control, it exists in level 4. The highest level is in level 5 that is used in large industrial plants to provide plant management with extensive process and operation informations and to perform production scheduling. So the typical DCS provides a wide variety of features and functions such as a control and monitoring, an interface to operation, and advanced application software. So we have the typical DCS features of functions. First is control and monitoring, an interface to operations, advanced application software. So we have the key points for this figure. It has the process control and monitoring is performed by DCS controllers, input or output system, and their associated field devices. Next, the typical microprocessor controller provides control functions from the simplest level, the pressure, the temperature, and the flow loops, to complete strategies involving interrelated loops and advanced process calculation. Most of these control functions are part of the DCS software. DCS controller also have built-in software logic functions that make it possible to interlocking and simple sequencing in addition to continuous control. Next, for the batch processing, distributed control system or DCS have advanced sequencing and batch control functions that can handle everything from single product, single stream processes to multi-product, multi-stream applications. The DCS human machine interface or HMI, it displays gives operation personnel the ability either to control and monitor across a broad area of plant or to focus on a specific area. The console can also send information and instructions to printers to produce periodic operation reports, alarm lists, printouts of graphics screens, and printed copies of process data. Also, DCS application software can do more than provide advanced control and monitoring of process plants.
Commercial distributed control system. So there are 8 elements processed in this part. First part is the local control unit. This is denoted as the local computer in the figure. This unit can handle 8 to 16 individual PID loops with 16 to 32 analog input lines, 8 to 16 analog input signals, and some limited number of digital input outputs. Data acquisition unit. This unit may contain 2 to 16 times as many analog inputs output channel as the LC. Discrete and analog input output can be handled. Typically, no control functions are available. Batch sequencing unit. Typically, this unit contains a number of external events, timing counters, arbitrary function generators, and internal logic. Local display. This device usually provides analog display stations, analog trend recorder, and sometimes video display for readout. Both memory unit. This unit used to store and recall process data. Usually mass storage disk or magnetic tape are used. Data, wait. Important consideration regarding to DCS. The basic units of digital computer. The digital computer used in DCS system is regularly a microcomputer with simplified components. It includes arithmetic unit which carry out arithmetic and logic commands. This control unit is the part of the computer responsible for reading program statements from memory, interpreting them, and causing the appropriate action to take place. The memory unit is used for storing data and programs. Typical computers have random access memories or RAM and are read-only memory or ROM. The final unit is the input-output interface. The input-output interface is necessary for the computer to communicate with the external world. This interface is the most important in the control implementation. The process information is fed to the computer through the input-output interface, and the commands made by the computer are sent to the final control element through the input-output interface. Process interface, a typical plant with large number of variables contains abundance of process information data. Therefore, process information can be classified under several classes or groups. Then a specialized device can be used to transfer all information of a specific class into and out of the computer. So there are types of categories of process information. First, digital, and the example of it are relay, switch, solenoid valve, or motor drive. Under generalized digital are laboratory instrument output, alphanumerical displays, pulse or train, or turbine flow meter, stepping motor, and lastly, analog type. Example of it are thermocouple or strain gauge, process instrumentation, other sensors. Timing. The control computer must be able to keep track of time in real time in order to be able to initiate data acquisition operations and can calculate control outputs or to initiate supervisory optimization on a desired schedule. The so-called real-time clock represents one technique. This device is nothing more than a pulse generator that interrupts the computer on a periodic basis and identifies itself as interrupting device. Operator interface. The operator interface is generally a terminal upon which the operator can communicate with the system. Such terminals usually permit displaying graphical information. Often these displays consoles are color terminals for better visibility and recognition of key variables. Digital control software. So that would be all, and thank you.
So in conclusion, digitally based control instrumentation represents a revolutionary change in the process control paradigm. With the digital system, a control engineer has the opportunity to go beyond the narrow limitation of standard and analog control components to construct a system that is optimum for the information, parsing, and control requirement of large process or even of entire plants. So, mo ni siya, this is why many industrial plants are updating their hardware and instrumentation system, bearing in mind that the payout times for installation and commissioning cost is as low as 3 to 4 months. So, mo na nga kuan. Dali siya mag-install. So, mga 4 to 3 months, yeah. Pag-install sa hardware, gamit tag kuan, DCS. So, Kyle and Kenneth, na mo idagdag sa atong report?
Nothing in particular. We would like to thank our great professor, Mr. Xavier Fernandez, for this great semester he have been given to us. And we have learned so many things from you, sir. Thank you. And Kyle, do you have any message?
Thank you for everything. And thank you for teaching us, sir. That would be
So, ako sir, magpasalamat sad ko. Thank you so much kay Marag sa imong subject nga gid mi sa tinud-anay lang na pressure gid mi. And kanang Marag imong exams kay makakurog gid usahay. Samot na gid ni face to face siguro. So para thank you rami sir kay para ma-extend sa among time sa report. Kay Marag kulang sa 30 minutes. So thank you so much sa mga experience na mo sa imong subject. So grabe kay Marag subject ni makatug og ng gay ba. So thank you sa bisag mga usay badlongon kay mi. Mora na sir. Salamat sa pagsabot nga di gid ni 30 minutes sa mong report. Basta sir, thank you kayo gikan ni sa mong kasing-kasing. Pasalo kami sir kung di ni malambot 30 minutes sa mong report sir. Mora na sir, amping always. Salamat kayo. Salamat kayo sa pag-teach. Salamat sa mga inputs. Mara na, sir. Unta maha-graduate me. Yay!
Good, Janay.
Graduate na ta, Grace.
Uy, 25 minutes ra gyud niya no report pa ya. Yan, dali na to. Ingon ba to, sir, nga di siya mo dawat if dili 30 minutes up. So na i-share guys sa para i-share sir kay para matas yung time. So actually bitaw sir sa kani sa duha nimo ka subject kay kanang sa instro ko gyud murag kuan ng lisod-lisod na part. Okay ra ang kuan ang distri. Mo ni ang experience ang distribution kay okay ra niya. Dire ako sa distri murag ang kanang gamay kay murag galibog ko sa high pero kasabot naman good na. Kinay tinuod sir. Ikaw Kenneth, unsa may mo Kenneth? Ningog mo. Last na ba yan ni?